recording and sharing my screen. And I'll leave it up to you. Did you want to look at questions that you have, or did you want me to go over those problems that we didn't quite look at from the function section last class?
I think it's like more of like the last 10 questions for me.
Okay, well, let me open the homework. And now, which assignment are you talking about?
Friday's
The one-
homework.
The one that's due this Friday?
Yeah, functions and graphs.
And it's March 26th, not February 26th. Okay. And I am guessing that there's a good chance that those might be very much like what I've got pulled out to look at. But so let's look at last 10 questions, 22. Yep. Can I show you what I had put in the notes to go over at the start of today?
Whatever's fine.
The functions range, the x-intercept if there is any, the y-intercept if there is any, and the missing values. So I think this is exactly, I think we're both on the same page. But if you want, we can start with the ones in the homework and do the other additional ones.
Yeah, that would be great.
Okay, so for this one, we're asking for a couple of things. First is, are you all right if I don't type the answers in and just write them next to the question so I can make the question
Sure.
to actually read? First thing we want is the function's domain. The domain would be the set of the x values of all the points. The function is this blue graph. As I look at that blue graph, you see how there's no spaces, there's no holes. All the numbers.
About like how we're getting there?
I can't hear you. I'm sorry.
Please mute themselves. Let's see if I stop sharing. I think there's a button for me to mute everybody. I don't think I need to use it anymore. So let me start sharing again. Maybe. I'm not going to be missing any values. It's all continuous. So now I have to say, is there a lowest x value for the points? So as I look at this blue line,
Hey, I'm sorry to interrupt, but Thomas is having a hard time joining the Zoom class. He says his password isn't working.
the password has not changed. The password should be MAT 110 with no spaces.
Yeah,
Yeah, I just
verified
joined.
that.
It should be working.
Yeah, everything, nothing's changed. You have him just exit and try again.
Okay.
Okay. So as I'm looking at this blue line, I'm looking for the x values of the points on it. And because it has arrowheads, it doesn't stop. And if I compare that to the x-axis, that is how far to the right it goes and how far to the left it goes. And you notice is I compare it to the x-axis because of the arrowheads. There is no stop or start. It just keeps on going in both directions. So the domain would be all real numbers. Wow, I have no idea why this is so sensitive. All real numbers would be the interval from negative infinity to infinity. Because of those arrowheads, it never stops. It just keeps on going. Now, instead, if I want to look at the range is the y value. So I want to compare that graph to the y-axis. If I look at the y-axis, see how those arrowheads are pointing down. So it's not going to have a lowest value. So the interval will start at negative infinity. But now as I look at it, you see how it tops out, it has a highest value. And that highest value is -1. And so the range would be everything from negative infinity to -1.
Okay.
X-intercepts is where it crosses the x-axis. And as I look at this graph, it doesn't touch the x-axis. So there are no x-intercepts. Y-intercept is where it crosses the y-axis. So you see it crosses the y-axis over here at this point. I'm going to put it in its coordinates, 0, -5. I can't remember how MyLabs asks you to answer it. They'll either just want the value -5 or they'll want it as coordinates. Now I'm going to erase all of the scribbling that I did on the drawing. Next thing asks us to find f of 1. So it's saying when x is 1, what's the y value? And so when x is 1, if I go down to my graph, you see how the y value on that point that has an x value of 1 would be -4.
These
Yeah.
graphs, I feel like, are so hard to read. Like, this looks like so many different things.
Okay, give me a second. I'm turning my finger back into a mouth. I'm erasing the screen. And if you press on the magnifying glass, it makes it bigger. If you press on the other thing, it gives you a very large graph. Does that make it easier for you to enlarge it to see it?
I mean, yeah, but like, I don't know.
But do you see how, I mean, for the x values, there's no furthest to the left. It just keeps on going. So it goes to -infinity. There's no furthest to the right. It just keeps on going. For the y values, there's no bottom. It keeps going down, -infinity, but there is a top. The highest y value is -1. I think the next part of the question said when x is, what's x is 5. And so when x is 5, I'm going to go down and say, okay, when x is 5, what's the y value of that point? And do you see how the y value of that point would be -2? And so f of 5 is -2. Let's do a few more of these. For the few more, rather than pulling the ones out of the homework, because it's tough to save what I write on the homework. Are you all right if I go through and pull the ones that I had inserted into the notes? It's same general type of question, just they're taken from a book instead of the interwebs. This question here, 78. Again, for each of these, we're supposed to find the domain. And remember that the domain are the x values. And so as I look at that blue graph, there's no breaks in it, so we're going to have an interval. Look at the arrowheads. The arrowhead says it just keeps on going. So there isn't going to be a furthest to the left value. So we're going to go from -infinity to, on the other side, there's an arrowhead. It just keeps on going. So there's no furthest to the right. So the domain is going to be from -infinity to infinity. If I want the range of the y values. Is there a lowest point? No, the arrowheads keep going down, -infinity. However, is there a high point? Is there a highest y value? Well, I think the highest y value would be right over here, which is 4. And it does equal 4. It touches that 4, so we'll have a closed interval. For this one, the x-intercepts. Well, it crosses the x-axis at -3 and 1. As points, it would be the point -3, 0, and the point 1, 0. Y-intercept, it crosses the y-axis over here at 3. That would be the point with an x value of 0 and the y value of 3.
Wait, so for the x-intercept, would I type in both of those? -3, 0 and 1, 0?
You would, you know what? Whoops.
I just don't even know.
Okay, for the intercepts, they're not asking it for it as a point, they're asking it just for as a number. So I apologize. Going back to this then, using that notation, the x-intercepts here, we would say where it crosses the x-axis would be the two values, -3 and 1. For the y-intercept, where does it cross the y-axis? It crosses the y-axis at 3. They are not asking for them as points. They're asking for them as single values. I apologize.
No commas.
Well, use a comma to separate answers as needed. So since there's 2 of them, you'll put a comma in between them.
Or I meant parentheses, I'm sorry.
No parentheses. And now over here where it asks for f of -1. I'm sorry, f of -2. When x is -2, I'm going to go up to my graph. And when x is -2, you see that point has a y value of 3. And instead, if I want f of +2, well, when x is +2, if I go down to my graph, it looks like I have a y value of -5. And I do apologize for not having done these examples last class.
Happens.
Yeah. I think 80 is very much like the first one that we looked at. So I'm going to go down to 82. For 82, we need the domain, the range, the x-intercepts, the y-intercepts. In this one, we just want f of -4. I'm going to shut up for a minute and ask you folks to try this one. And then we'll go over. And if you need, we can look at some more from the homework too. Are you guys ready to go over or not yet? Ready?
Yep.
Okay, for the domain, we want to look at the horizontal movement. The furthest to the left it goes is -6. But notice at -6, it's an open dot. So we're not equaling -6. So we're going to put that rounded parentheses there. And then the furthest to the right it goes is when x is 0. And that's a closed dot. So it can equal 0. range, we're looking at the y values, we're comparing it to the y-axis. The lowest that it goes is negative. It's a closed dot there, so we're including it. The highest it goes is 4. It's an open dot there, so we're not including it. Could everybody who's not talking, please mute yourselves? X-intercept, it crosses the x-axis at -4. Y-intercept, it crosses the y-axis at -3. And for f of -4, well, when x is -4, the y value is 0 because that would be the point, -4, 0. Any better?
Yeah, actually, it is better.
Okay. And I should have gone over these 3 last class. I apologize. I hadn't uploaded them into the notes. And I should have fumbled with a virtual textbook. Do you want to look at more of these from the homework? Or
Yes,
do you-
please.
Okay, pick a number, any number.
20 or 24.
24. 24. Does your 24 look a little bit like this?
Crap. Yeah, it does.
Okay, so then for 24, the first thing we're looking for is the domain. The domain are the x values. The smallest x value over here, the furthest to the left it goes is when x is 0. It's a colored in dot, so I'm equaling 0. But now, is there a highest value or does it keep on going?
Keeps going.
It keeps going, so it goes from 0 to infinity. Remember, infinity is a concept, not a number. We can't equal it. So it'll always be that rounded, that open interval there. For the range, we're looking at the y values, so we're looking for how low does it go. And again, because this arrow is going, it's not going real steep down, but it keeps going down, 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 down. So it has no lowest value. So we're going to say negative infinity. But for the highest value, it looks like the highest y value, the top here, is at -2. And it's a closed dot, so we'll have a closed interval.
What the heck?
Somebody at the gym?
Sounds like it.
Next is the x-intercept. Does this thing cross the x-axis?
No.
So there's none. For the y-intercept, does this thing cross the y-axis?
Technically, yeah.
Yeah, at -2. And I have to apologize. I don't think, oh, we want f of 1. Well, can I put it back where it was? Maybe. F of 1.
How do you determine if the F is for X or Y?
F of x, it's always f of x equals y. So what's in the parentheses is always the x value of the point, and the function value, f of x, is always the y value. So over here, when they're saying f of 1, they're saying when x equals 1, what's y? And so f of 1 is a shorthand way of writing that. It's saying in the x place, I've got 1. What's the corresponding y value?
-3.
Beautiful. And so the value, when we've got that function notation, the value in the parentheses is our x value. And what that f of x equals is our y value. Better?
Yep.
Does anybody else want to look at anything else? Or do you guys want to look at another one of these, or are we good now?
I'm down to do one more.
Okay, which one?
Just the next one.
Okay. Oh, this one's not too bad. We want f of 2. I'm going to make it a little bit bigger. And I'm going to shut up and see what you guys get.
He's definitely playing basketball.
You got to mute him. Give me a second.
Oh, man.
Like what even?
I don't know, man.
That doesn't count as attendance, does it?
I
Sure
don't
doesn't
know.
add up. Aha, math jokes.
F of, what are we looking for? F of 2.
So -2, 6.
Wait, no, be quiet. We're not working on them yet. I'm muting people.
Okay.
Okay. Hopefully the background noise is gone. Are we ready to go over, or are we still working?
Get the hang of it. I'm ready.
How did I do? Did everybody get that the lowest x value is -2, the highest is 6? So the domain is the closed interval from -2 to 6.
Yeah, that one was easy. It's actually 26 that's kind of hard.
Oh, jeepers creepers, you guys are having me do all your homework for you today. All right, one more.
I mean, we got to be able to do it.
Yeah, on your own.
We're
Isn't
learning.
bad.
We're
What's wrong with
learning.
It's a
26.
learning experience. It's not bad for you. You're the teacher.
What? Tell me what you're struggling with.
Wait, that one looks different than mine.
What's yours look like?
The same thing, but that bottom bar is like on the x-axis, or no, it's right below it.
It's okay. It's the same general shape, right? It's
Yeah,
just
yeah.
moved in the plane. So we'll do mine and you'll have to do yours on your own.
All right.
All right. Domain. Oh, Lord. I'm drawing straight lines. That's not what I want.
It's infinity.
I'm going to shut off. You guys do it and we'll chat.
Okay.
I read earlier. Yeah, I found like yesterday I gave some guy a LR and get day. I just joined that we did already.
Are we ready to go over yet?
Yeah, I'm ready.
Okay, domain X values. It keeps going to the left, it keeps going to the right, so it's all real numbers, negative infinity to infinity. Range, the Y values. The lowest that this thing goes is 4, and it keeps going up from there, so it's the interval closed at 4 to infinity. X-intercept, that thing doesn't touch the x-axis anywhere, so there is none. Y-intercept, we cross the y-axis at 6. F of 1, well, when x is 1, y is 5, so f of 1 is 5. F of 4, when x is 4, y is 4, so f of 4 is 4. Any better?
Yeah. I definitely learned how to do it.
Well, if you still have questions on them, it's not due until the end of the day Friday.
It's really, I think, really just now. It's like the last 3 questions, but I guess I'll figure that out.
Are
for
they more
myself.
of the same?
No, it's not this stuff. It's different.
Oh. Okay, over here with this one, we know that f of x, we're told, is x cubed minus x plus 9. So that's the f of x. We need to find f of negative x. And for f of negative x, where there's an x, we're going to put in negative x. And when we simplify that, we get negative x cubed plus x plus 9. So far, so good.
Yeah.
Now all we're going to do is we're going to subtract those two. It'll be f of negative x, which is the negative x cubed plus x plus 9, minus f of x, which is the x cubed minus x plus 9. And you're just going to go through and subtract them. All right, I'm going to leave the subtraction for you guys. Next one asks you to do a couple of things. First one, it says that you've got 2 functions here, f of x and g of x. So first of all, you want to find f of 70. Well, let's see. The functions model the chances as a percentage that a 60-year-old will live to the age of x. The bar graph shows the chances of a 60-year-old surviving to different ages. So f of 70, well, if f of x is negative 2.8x plus 286, f of 70, we're just going to replace the x with 70. And then you're going to evaluate that. And this says that that's the chance is a percent. So it'll be whatever that number is, that percent chance that the somebody will, who's 60 now, will live to the age of 70. Then you're going to do the same thing, plugging in 70 for x in that other one, g. And then we're going to look at the graph, and the graph says that the actual chance was 93. So you're going to say which of those two is closer to 93? Is that one okay?
Uh, 1 second.
And then 31. Says that a company manufactures bicycles. It has a fixed cost of $90,000. It costs $200 to produce each bike. The total cost for the company is the sum of its fixed costs and its variable costs. Write the total cost C as a function of the number of bicycles produced, X. Okay. So the cost is the sum of its fixed cost. Well, what's its fixed cost? Think over here, the fixed cost is $90,000. Sum means I'm adding the variable costs. Well, what's variable? It costs $200 to produce each bike. And so if I'm making X bikes, well, wouldn't that mean it would be $200 times the number of bikes? And because we're calling this a function, rather than just saying that C is equal to that, we're going to say C of X is equal to that. And then they want you to substitute into your function to find C of 110. Better?
Yes.
All right. Then, does anybody else want to look at anything else from this homework? If not, I'm going to get out of here. Whoa. And did somebody have another homework
It's
question? You okay? Then, last class, we talked about the functions and we talked about linear functions. We said that the general form is ax plus by plus c equals 0. We said that the graph is going to be a line. And we said to graph it, we can always make a table of values. We'll have other methods of graphing, hopefully some of them after today. Then we said we sometimes talk about the slope of a line, which just tells us something about its slant. And we said that slope is usually represented by a lowercase m. And if I'm looking for the slope between 2 points, it's the difference of the y values over the difference of the x values. Where x1, y1 is 1 point, and x2, y2 is the other point. And we graphed a line, and we found the slope of the line that we graphed. But let's go through and let's practice using this slope formula. Let's find the slope of the line through the points let's say I've got 1, 4, and 3, -2. And so I'm going to ask you folks to use that slope formula to find that slope. And remember, we had said with slope, it's important that these two are from one point and these two are from the other point. Doesn't matter which you consider your first point or your second point. What matters is that you're consistent. And while you folks go through and find that slope, I'm going to take the liberty of graphing those points. Did anybody else get a slope of -3?
Yeah,
And does everybody notice that if the slope is negative, the line goes downhill as I look at it from left to right? Or if m is less than 0, we can say that our function is decreasing. Let's try another one. Let's find the slope of the line through, let's have, this time, let's have the points 0, 3, and let's say 3, 4. And again, you're going to use that slope formula. Did anybody else get a slope of 1/3?
yep,
And again, that slope of 1/3, if the line were graphed already, we could have found it by saying it goes up 1 and over 3. And since that slope is positive, our line goes uphill or it's increasing. And I want to just compare those two for a minute. I'm going to shrink it down so I can look at both the lines in one screen. Do you notice the line that's downhill is much steeper than the line that's uphill? Because it has a greater absolute value. The larger the absolute value, the steeper the line. So it is a measure of steepness, a measure of slant. Another one, let's find the slope of the line through, let's say, 1, 2, and 4, 2. And again, I'm going to take the liberty of making a rough sketch. Did anybody else for this one get a slope of 0?
Yes.
And if I look at my line, do you notice that if the slope is 0, it's a horizontal line? Because in order to be a 0 slope, the y values are the same. So if the slope is 0, we have a horizontal line. Gonna write that if slope is 0, line is horizontal. And one way I've seen of remembering that is that 0 starts with Z and horizontal has a Z in it. As I look at this being horizontal, because the y values never change, and the y values are the function values, we're going to also say that if the slope is 0, we have a constant function. We looked at this as f of something. F of 0 is 2, f of 1 is 2, f of 2 is 2, f of 3 is 2. That function value is always the same. And one more practice with slope. Let's ask you to find the slope of the line through the points, let's say 2, -2, and 2, 3. In using the slope formula for this one, because the x values are the same, did everybody get a 0 in the denominator? And we've said over and over and over again, that can't happen. We can't have a 0 in the denominator. So here we don't have a slope. The slope is undefined. And so if the slope is undefined, notice that happens when the x values are always the same. And that happens when I have a vertical line. And so I'd like to look at each of those 4 cases for a minute. I hope I don't hurt anybody's eyes too much by shrinking this down so that all 4 graphs are on the same page. Can I get it that small? No, I'm going to have to bounce up and down a little bit. This first line, if I were to look at that vertical line test, does everybody see that this first line is a function? The second line, if I were to look at my vertical line test, this one is a function. This third one, if I were to look at my vertical line test, any vertical line test is only going to cross it once, so it is a function. But this last one, if I were to do my vertical line test, does everybody see right over here when x is 2, it fails. And so this is not a function. And I know it's a lot of generalization, but does it make sense looking at those few lines that we've got, that the only time a line is not going to be a function is if it's vertical? The only time a linear equation is not a function is if it's a vertical line with no slope, or rather than no slope, where the slope is undefined. So any line is going to represent a function unless it's a vertical line. You need to remember that. You need to remember that if the slope is positive, my line's increasing. If the slope is negative, my line's decreasing. If the slope is 0, my line is horizontal. And if the slope is undefined, my line is vertical. Slope's okay so far. Any questions? Is everybody one with that slope formula? That's a formula that you do need to know. And if you know that formula, it's very easy to remember the next formula. And the next formula that we're going to use to find the equation of a line. And in order to find the equation of a line, we have to know something about the line. So try to picture a line somewhere on a plane. In order to describe it, wouldn't we need to know how slanted it is? So we need the slope. And then once we know how slanted it is, we need to know where it is in the plane. Is it up high? Is it down low? Where does it go? And to find out where it is in the plane, we'll get that by knowing one point on the line. And so if we know how slanted it is, and we have a point to put it through, that will give us a single line. And to find the equation, we need to know the slope and one point. And so we're going to use what's called the point slope formula. And so the point slope formula is going to be used to find the equation of a line with a given slope. So we have to know what the slope is. We'll use m for the slope through a given point. And so we need to know one point. So it'll be x1, y1. And we're going to use that to find an equation that will describe all of the other points on the line. What I'm going to do first is give you the point slope formula. The point slope formula is y minus the y value of the point, y1, is equal to m, the slope, times x minus the x value of the point, x1. And so this is our point slope formula. And I think it's obvious. I'm no genius. I needed a memory aid to help me remember these the first time I saw them. And so that's where I think that if you can remember your slope formula, you know your point slope formula. And so I'm going to take a minute to kind of just show you a real quick derivation of the point slope formula. The one formula that we know, it's our definition of slope. Slope is the difference of the y values over the difference of the x values. This one, the second point, I'm going to call x1, y1. That first one, I'm going to leave the subscripts off. I'm going to get rid of the little twos because we're looking to describe a general line. Now, when I have an equation like that, I'm going to rewrite it a little bit, where I have a fraction on one side and a constant on the other side. If I put that m over 1, do you see how now all of a sudden it's a proportion? And is there anybody else that had it drummed into you in your formative years? If you have a proportion, you want to cross multiply. And so if I cross multiply along one diagonal, I get 1 times y minus y1, which would just be y minus y1. And on the other diagonal, I get m times x minus x1. And so do you notice that this point slope formula is really just what happens to my slope equation if I cross multiply and get rid of the little twos? Which I don't know if that'll help you remember it. I know it helped me remember it, to think that I'm just cross multiplying with that formula that I know already. So let's go through and let's use it. Let's find the equation of a line with a slope of, let's start with an easy number, 2, through the point. Let's make our point be something like 1, 3. We're going to look at this in a couple of different ways. In the homework, they're going to ask you for it in point slope form. They're going to ask you to write it like a function. And like writing it like a function will also be called the slope intercept form. And they're going to also ask you to do it in general form. So, point slope form. Our point slope formula is y minus y1 equals m times x minus x1. I'm sorry, this pen is super sensitive today, and even though I lift it up, it leaves marks, and it's making my penmanship look worse than normal. I apologize. Looking at the given information, we know the slope is 2. If my point is 1, 3, does it make sense? X1, the X value is 1. Y1, the Y value is 3. And so when I substitute in, I get Y minus 3. The Y value is equal to M, the slope, well, that's 2, times X minus the X value is 1. And in point slope form, that's my final answer. Don't take it further. The only thing you might do beyond that is if you're subtracting a negative number, you might replace the double negatives with a plus. But otherwise, stop there if they want it in point slope form. If they want it as a function, or if they want it in slope intercept form, what that's asking you to do is to take that equation and solve for y. And I think most people intrinsically want to do that. They want to, when you see that number in front of the parentheses, don't you want to distribute? And so let's distribute. That gives me y minus 3 equals 2x minus 2. And then that looks messy. Let's get all of those constants together. And so that gives me y equals 2x plus 1. And that's solved for y. That's written as a function because it's solved for y. That's going to be what we refer to as the slope-intercept form. And then general form, well, I go back to the top of that last page. We said that general form, one side is 0. So to put it in general form, we want one side to be 0. And so to make one side 0, I'm going to subtract y from both sides. That gives me 0 equals, it's most normal to put your variables in alphabetical order. So let's go 2x minus y plus my constant. And so this is my general form. Not too bad. So let's try another. Let's find the equation of a line with a slope of, let's make our slope this time 3/2. And let's have it go through the point -4, 5. We want it in slope, point slope form. We want it in slope intercept form. And we want it in general form. And again, we're going to use it y minus y1 equals m times x minus x1. And I'm going to shut up for a minute and ask you folks to do this. I'll be right back. How are you folks? Did everybody recognize that M is 3/2, X1 is -4, Y1 is 5. And so when I substitute into that point slope, I get Y minus 5 equals 3/2 X minus -4, but that minus and minus I'll write as +4. Stop there for point slope form. Then for slope intercept form, when I solve that for Y, I need to distribute. I get 3/2 X plus 3/2 times 4 gives me 6. And then getting Y all alone, when I add 5 to both sides, I get Y equals 3/2 X plus 11. Then for general form, I want to make one side 0, so I'll subtract Y from both sides. And that gives me 0 equals 3/2 X minus Y plus 11. And I think that's acceptable. But usually you want to make it look a little bit prettier than that. Normally for that general form, you want to clear the fractions. And we've done enough with rational equations and rational functions to know the way to get rid of the fractions is to find that denominator and multiply both sides by it. 2 times 0 will still be 0. And over on this other side, when I distribute that 2, I get 3x minus 2y plus 22. And it's equivalent. I do believe that in my labs, they'll accept either of those two answers, but the second one just looks a little bit nicer. So far, so good. If so, we're going to look at a couple of special lines. Let's find the equation of a horizontal line through a given point, let's say through the point 1, 2. We're going to look at this two ways. First, let's be very rigorous and think of using our point slope formula. So with the point slope form, when I have y minus the y value is equal to the slope times x minus the x value, we have to remember that if it's horizontal, the slope is 0. And so I get y minus 2 equals 0 times x minus 1, which would just give me y minus 2 equals 0, or just y equals 2. And does it make sense? Anytime I have a horizontal line, my slope will be 0, and when I multiply by 0, the right-hand side of the equation will disappear. And so we don't need to replicate this work if we can just remember that horizontal line is that constant function. The y value is always the same. And so a horizontal line will always have an equation y equals some number b, where b is the y value of any point on the line. And so if I can remember that, I don't need to do this work. If I can remember that, I know that Horizontal line will always just be y equals a number. What number? The y value of my point. Instead, if I want a vertical line, let's go through that same point. Well, a vertical line has no slope. The slope is undefined. So I cannot use my point slope formula. I have no slope. And so a vertical line, remember, in order to be vertical, the x values were always the same. A vertical line will always have as its equation x equals some quantity a, where a is the x value of a point on the line. Because I have no slope, I can't use my point slope formula. And I have to remember, if it's vertical, the x is always the same. And so this equation line would have as its equation x equals the x value of the point 1. So a horizontal line will always be y equals the y value of a point on the line. A vertical line will always be x equals. And it will equal the x value of the point on the line. Pretty cool? Another example. Let's find the equation of the line through, well, let's have it go through 2 points. Let's have it go through 1, 5, and 3, 9. Oh crap. We said to find the equation of a line, we need the slope. But sadly, we don't have a slope. What are we going to do? Any ideas?
Figure out the slope from the 2 points.
Yeah, first thing we want to do is find the slope. So my slope formula is the difference in the y's over the difference in the x's. So that'll be 9 minus 5 over 3 minus 1, which would give me 4 over 2, or 2. And now we have the slope. We'll use the point slope formula. And it doesn't matter which point I use. I can use it with either point. Usually we don't do it twice, but I'm going to do it twice just this one time to show you that either point works. Point slope formula is y minus the y value is equal to the slope times x minus the x value. If I use the 0.15, that would give me y minus the y value is 5 is equal to my slope 2 times x minus the x value is 1. So that gives me y minus 5 equals 2x minus 2, or y equals 2x plus 3. Instead, if I use the other point, if I use that 0.39, I'd have y minus 9 equals 2 times x minus 3. And right now they look significantly different. But if I clean them up, y minus 9 equals here distributing 2x minus 6. And when I add 9 to both sides, I get y equals 2x plus 3. And so do you see, it just doesn't matter which point you use. You should get the same results with either point. And do we go to quarter of or 10 of?
Quarter.
Yeah, that's what I thought, which is not what I wanted, because that means we have 2 minutes. And the next concept that I want to talk about takes more than 2 minutes to develop. So sadly, we'll stop here and we'll try to talk a little bit faster on Friday to get ourselves up to snuff. At this point, though, how are you folks feeling? Is everything okay? Am I going too fast? Am I going too slow? Or are you, is it all right? Is this brand spanking new to any of you? Does this look vaguely familiar? If it looks vaguely familiar, is this enough of a nudge to your memory? If it's brand spanking new, are we spending enough time with things? How's it going, folks?
It's coming